පෙන්නනවා ධම්මික. කොලේක කියලා මොනවද පෙන්නනවා.
Now I fill the burette again with hydrochloric acid to make sure that I don't have any spills, and I would put the tip move any hydrochloric acid. Right. Then what I do, I'm going to do the titration again with in the presence of methylene. So this is the second trial. Add some sodium carbonate to the burette to the beaker. And again, now I'm going to get the sodium carbonate into the graduated pipette. Can you all remember that the pipette should be at the vertical position, and you can slant the beaker. Right. And transfer it to the titration glass, and when you are transferring the solution to any glassware, make sure the pipette should be at the vertical position, so you can slant the position of the glassware. All right, now I transferred sodium carbonate into the titration flask. Then again, I'm going to do the titration with phenolphthalein. Drop of that. See that the color changed to pink because it is a alkaline solution. Right. Now, before starting the titration, I have to raise the burette a little bit more. And then the initial burette is again 0. Again, I start to do the titration to get the burette reading for the second trial. So I'm adding hydrochloric acid dropwise to the sodium carbonate solution. As you can remember, the color change that I expect at the end point is pink to colorless. So during the titration, when it reaches the end point, you can see that pink color fades out and convert to totally colorless. Let's see. When you do the titration, you have to add hydrochloric acid dropwise, and you have to swirl the titration flask very well. Those two activities should happen at the same time, simultaneously. I always say this to you. As the pink color fades out, you can see that the end point is almost there. We'll add another drop and see. Another drop. One more. Now it turned to totally colorless. So we are done with the second trial for phenolphthalein, and the burette reading is 10.4. Right. Now I'm going to transfer another 10 milliliters of sodium carbonate. I'm going to take 10 milliliters of sodium carbonate into the graduated pipette. And then I'm going to transfer that to the titration flask. right? And this time I'm going to add methyl orange as the indicator. This is the second trial with methyl orange. Add 2 drops of methyl orange, and you'll see that the contents in the flask turn to yellow because it's an alkaline solution. Right. Now, again, we are going to do the titration with hydrochloric acid. Now, we are titrating sodium carbonate with hydrochloric acid. The presence of methyl orange as the indicator. I started the titration. Now I'm adding hydrochloric acid dropwise into the titration flask. Now, what is the color change that you expect? Yellow to slightly red. So what do I add now? Hydrochloric acid dropwise. While I'm adding hydrochloric acid dropwise, I have to swirl the content in the titration flask. Why should I swirl the contents? Because I have to mix the contents very well, no? For a reaction to happen. It still is yellow in color, and at the end point, you expect it to turn to slightly red. So I'm waiting till I get that slightly reddish color, because that is the color at the end point. So what the color change that we expect is like yellow to red. It's almost there. We'll add another drop and to see and see. So it has turned to slightly red in color. And the burette reading is 33. 33. So now you know the burette readings for the titrations that I performed by using phenolphthalein and methyl orange as the indicators. You can tabulate the data, and I will send you the worksheet. You don't have to write a lab report this time. I will send you a worksheet. I will email that to you. You have to fill that, but to do all the necessary calculations, you have to know the burette readings, which I told you while I was doing the experiment. Calculate the sodium carbonate concentration by using both the burette readings, the reading with phenolphthalein and methyl orange, and you have to compare the results, and you have to discuss why that we see different color changes, and what is the reason behind the theory, the actual theory behind the behind using two different indicators. I hope the experiment was very clear to you. Are there any questions that you want to ask from me? Guys, we conduct the
Sir,
yeah, go ahead.
what was the last burette value?
It was 33.1.
Thank you, sir.
Right, guys, I know this could be your first WebEx experience, so make sure on the other days you have to mute your microphone because some of your colleagues have got kind of like disturbed from your background noises. So on the other days, make sure that you are going to mute your microphone while watching and listening to me. All right, people, are there any other questions or concerns or anything that you want to ask?
Sir, what was the initial burette value for the last titration?
It was 10.4.
Thank you, sir.
Any questions? This is the time that you got, like probably after 2 months, to talk to me, no? So if you have any questions regarding this, because or else could be something else, even, you are welcome to ask.
So do we have to calculate the concentration of Na2CO3 presence of both indicators?
Can you say it again? Can you repeat that question? I didn't get you clearly.
Do we need to calculate the concentration of Na2CO3 with the presence of both indicators?
Yes, you have to. You have to calculate the sodium carbonate concentration in the presence of both indicators, and you have to compare the results.
Separately.
Separately, yes.
And do we have to tell what is more suitable for the titration? What indicator was?
No. You don't have to say like that. You have to simply explain the theory behind using two different indicators. That's all. Come on, people, ask more questions.
And so do we have to compare it with the actual concentration of Na2CO3 we took?
Very good, very good. Yes, actual concentration is 0.1, right? Guys, make sure the actual concentration is 0.1 mole per cubic decimeter. You have to compare your value with the actual value, and if it has been deviated, you have to state why.
And by that, can we say that this indicator is more suitable and this is not suitable like that?
No. Now, when you do the strong acid strong base titration, hydrochloric acid and sodium hydroxide titration, we use three different indicators: phenolphthalein, methyl orange, and hexamer blue. In that, of course, we discussed what is the most suitable indicator for that type of a titration. But here we don't do anything like that. Here we have to know the theory, the reason behind of using two different indicators. That's all.
Thank you very much, sir.
You're welcome. Are there any questions? Guys, feel free to ask from me. Huh?
Sir, what was the concentration of HCl that we used?
That was 0.1.
Okay,
Good
so
question.
both were 0.1?
Both were 0.1, yeah.
Thank you, sir.
Any other questions? Guys, open your mouth and talk now. If we don't, I mean, like, if you all don't have questions, then I guess like we can wind it up. Still, the platform is open to you. Just if you have questions, ask. It's like an opportunity for you to talk. Rather than emailing me the questions, I mean, like, I can verbally answer your questions now. No? All right. Then now, tomorrow, most probably at the same time, we are going to do another experiment via WebEx. So get ready for that. It's going to be a total new experience to you because you haven't done any that type of experiment in the laboratory. It's again going to be a demonstration, of course, online, but make sure that you are going to come online mostly at 1 o'clock. I will send you all the details as I did it today. So I would
Excuse me,
be much
sir.
happier if you can read about oxidation reduction titrations before tomorrow's session. So tomorrow's session is on oxidation reduction titration. Right. So tomorrow, most probably at the same time, I will see you all. Till that, then, bye-bye.
Excuse me, sir.
Yeah, go ahead.
Do we
Some
have
of our
calculated
friends
standard
out there,
deviation?
they can't. Okay.
Say it again.
Some of our friends out there, they can't join the video because the limited participants and it's like more than 100 participants. They can't join this. I mean, like 20 of our friends are out there.
It cannot be no, because when we use the WebEx, we can go more than 100 for sure. That's why we have
Yeah.
chosen WebEx to do the online sessions.
But they got the message like it's full of 100 participants and you can't join like message. That's why I'm told that.
All right, I have to look into that matter. In that case, it shouldn't be a problem because like I'm going to upload the recordings as well, but that doesn't mean that you are not going to participate for tomorrow's experiment because I'm going to upload that. You have to be online because I can see each and everyone who were online and who were not online. So anyway, if there is a person or few of you all that you couldn't really join online, don't worry, I'm going to upload it.
Thank you, sir.
You're welcome. Are there any questions, any concerns? No? All right then, bye-bye. Tomorrow at the same time, most probably I will send you an email.